All right, so like I said, today we're going to talk about something called composite functions. And when I just asked you guys what composite meant, you said more than one thing makes it up, right? The same thing happens with the functions. So this right here says f of g of x. It means the same thing as this one. And really what this says to do is put whatever you're doing into the g function first, and then put it into the f function. So we're really just doing more than one function at a time. Okay, so what does this one say to do? Anybody? Yeah, f first and then g. So if there's a number right here, like 2, we would put 2 into the f function. And then when we got that answer out, we would put the answer into the g function. That's how composite functions work, okay? Lots of people like to call this fog. Lots of people like to call this goth. I don't care if you call it that, but it's really just the composite function of f and g, or the composite function of g and f, okay? So let's start with some numbers and see what happens here. What does this ask me to do if I look inside the parentheses? Put 4 into the g function. So we've done that. We're going to just substitute 4 into the g function. So I'm going to have negative 5, and instead of x, what am I putting? 4. And then plus 9. So what do I get when I do that? This would be a negative 20.
Negative 11?
Yeah, negative 11. Okay, guess what I'm going to do with that answer now? Yeah, because if I were to write this back over here, g of 4 was negative 11, right? So all of that part right there could be replaced with the negative 11. So now I'm putting negative 11 into the f function. So I would have 3 times negative 11 minus 5. What'd you get when you do that?
Negative 38.
That's right, negative 38. So my answer for f of g of 4 would be the number negative 38. How many of you guys already like this better than the other stuff? Like, I love doing composite functions, okay? All right, so this next one, what does it ask me to do first? Put 4 into the f function. So we're going to substitute 4 into the f function. The f function is 3 times x minus 5, and instead of x, I'm putting in 4. 3 times 4 is 12. 12 minus 5 is 7. And then what am I going to do with the 7? Plug it into g. So put it into the g function. So negative 5 times 7 plus 9. Let me know when you get that. It is negative 26. Okay. I do want to point out one thing right here, which is the reason why we did these two problems. Do you see how it was the same number that we put through the functions, right? We started out with 4. I want to point out here that order did matter. We did get 2 different answers, right? When we did the commutative property the other day when we were doing addition, it didn't matter which order, but on composite functions it does matter, okay? So you always start with the innermost part and move your way outside. All right, so what's number 3 asking me to do? Yeah, put this into the f function, and then we'll get our answer and put it through the g. So if we put it into the f function, we're going to have 3 times negative 3 minus 5, substituting it into f. When I do that, I get, yeah, negative 14. Nice job. What am I going to do with that negative 14? Yep, put it into g. So the g function is negative 5 times x plus 9, but instead of x, I'm going to put in negative 14. What I get out for that answer is my solution to this composite function. So, shout it out to me. 79? Thank you. Questions on how I'm getting these answers? All right, I'm going to give you a head start on number 4 then. Try to do it on your own. You're putting it through the G function first, then you're putting it through the F function. Shout it out to me when you get an answer. I haven't done it yet, but let's see if you get the same answer as your neighbors. 67. Anybody else get 67? Nice job. Okay, Preston, do the work. All right. We're putting -3 in for G, in the G function, I should say, in place of the X. So it'll be a -5 times -3 plus 9. So that would be a -15 plus 9, which comes out as, because this would be a negative times a negative. That would be 50. Oh, it is 24. You're right. I'm thinking I was wrong. Okay. 24 goes into the F function. So 3 times 24 minus 5 would be 72 minus 5. So 67. You guys are right. Nice job. Okay. All right. So the next thing we're going to do is exactly the same thing, but this time we're doing it with variables instead of with numbers. Okay. So what does it tell me to substitute into the G function? X. So where I see an X, I'm leaving it an X. Okay. So this whole G function right here, if I put the X in for X, I would end up with 6X plus 2. Do you guys agree with me on that?
Very agreeable.
Then what do I have to do with that part? I have to put it through the F function. So in the F function, when I see X, what am I substituting in for it? 6X plus 2. Okay? So my F function is normally X plus 4, but what am I going to put in place of the X? 6X plus 2. So I have 6X plus 2 that I'm substituting in place of the X, and then I would have plus 4. So my answer is going to be 6X, combine your like terms here, plus 6. Okay? Yeah, that's a lot of 6s. Okay, the point to be made here is this. If you have a number inside here and we're substituting in when there's only one variable, we're going to get a number out for our answer. If we have a variable inside here, guess what we should be getting out? Variables, right? It would make sense that that would happen. Okay, this time we're going to go the opposite direction, and we're going to do F first and then G. So if I look at my F function and I leave the X where it's at, I still get X plus 4. Does everybody agree with that? So what do I have to put through the G function? I have to put X plus 4 through the G function. So instead of 6 times X plus 2, I'm going to put that into X instead. So I'll have 6 times X plus 4 plus 2. You guys following me all right? So we're distributing that through to get 6X, and right here to get 24.
666.
And then plus 2 at the end.
There is, look at that.
Like right in a row. That's, math is the devil's work, huh? Okay. What do I get right here when I add those? Yeah, because we needed more 6s, right? Okay. Questions on how I did that, though? It's still the same thing we did. We're just doing it with variables instead of just with numbers, okay?
Yo, I got an Instagram. I'm sorry.
Oh, no, you're not checking that right now.
It's such a good coincidence.
Okay. F of G of X plus 1. This time, instead of leaving the X where it's at in G, I'm going to replace the X with a X plus 1. So I go up and I grab my G function, which would be 6X plus 2. And what am I going to put in place of the X? x plus 1. So I would have 6 times x plus 1 plus 2. We're going to distribute that out, combine like terms, and then put it through the f function. So here I would have 6 times x, which is 6x.
There we go again.
6 times 1, which is 6. And then add the 2 on the end. So what did I get out? 6x plus 8. I'm not done though, because what do I have to do now? I still have to put it through the f function. So I'm going to come over here and I'm going to write down my f function, which is 3x minus 5. And this gets substituted in place of the x in the f function. So I'm going to have 3 times 6x plus 8. And then minus the 5 off. All right, we're almost done. What's 3 times 6x? 18x. And what's 3 times 8? 24. I'm going to minus the 5 off the end, and I will be done. I have 18x, and then 24 minus 5 is 19.
I think you got the wrong fx. You went up one, Julie.
Did I?
Yep, because it's...
Oh, you're right.
Why are you getting the wrong answer?
Yeah, thank you for pointing that out. Lorraine is right. I grabbed my f of x function clear from the top, and I should have grabbed it right here, which would have been x plus 4. That would have been an easier way to do it if I would have grabbed this function. But the point being, the work would be similar. I just grabbed the wrong function. Do you want me to redo it, or are you okay with it like that?
Yeah.
We're okay? All right.
Okay.